Let's take a look at this optimization problem here. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions of the box that minimizes the amount of material used. Let's draw a picture of this. A square base, so it'll look something like this maybe. Now I don't know right now if the box is tall or short. I'll just draw it maybe a little bit taller. Could be shorter though. We'll see. Kind of running out of room here. Let me move that. So there's my attempt at drawing a box with an open top. We know that the box has a square base, right? So we can call this x and this x. And the height we don't know, so we need to use another letter. Let's call it y. Let's call v the volume of this box. What's the formula for volume of a box or a rectangular prism? It's easy. It's length times width times height. So you just take these three dimensions and multiply them. So x times y, right? And we can write that a little bit nicer as x squared y. But the thing is, we're told the volume is 32,000. So let's put that in place of v. And you know, usually with optimization problems, you want to eliminate one of the variables. So why don't we eliminate y or solve for y? So that means y is equal to 32,000 over x squared. Okay, so we're going to need this later. The next clue that we're told is that, well, it's not really a clue, it's the question. We want to minimize the amount of material used, right? That's basically the area, isn't it? So we need to get a formula for the area of this box. So let's call A the area. What is the formula for the area going to be? Well, how many sides, how many faces does this have? We have, notice we don't have a top, but we do have these four faces here. And there's also a face at the bottom that's hidden. So we really have 5 faces to consider. Each one of these faces, it's x times y, the area, right? The area of a rectangle is length times width, so x times y. Here is x times y, and also for those ones. So we have xy plus xy plus xy plus xy, because there's 4 of them. And we can just write that as 4xy. And the bottom here that we can't see, it's a square. It's x by x, so the area is x times x, which is x squared. Now, like we said, we want to get this as a formula that's all in one letter, let's say x. So we need to get rid of this y. Well, that's no problem. We know that y is really equal to this in terms of x, so let's make that replacement. And I'm going to write a of x now to emphasize that this is now a function of x. And y is 32,000 over x squared plus x squared. Let's simplify a little bit. The 4 times 32,000 is 128,000. And then x on top and 2 copies of x on bottom. One of them cancels away and I'm left with x. And this x squared stays. So we have a formula for the area function. And really, you know, since the question asks to minimize the amount of material used, our goal here is to minimize the value of a. What value of x makes this function a minimum? Or what value of x produces the minimum value of this function? All right. Well, the way we usually do that is by finding the derivative and setting equal to 0, right? I guess I should just be a little more careful here. I should say what the domain is. Since x is the side of a geometric shape, it has to be positive, right? And there's no other real restriction other than that. So the domain is from 0 to infinity. Now let's find the derivative. Well, remember the derivative of 1 over x? It's negative 1 over x squared. So, well, how about I go slow here? I'll just to make sure you understand. I guess I could write this as 128,000. Notice this is still a of x. I haven't done the derivative yet. Times 1 over x plus x squared. Now, what's the derivative? 128,000 times the derivative of this. This is like x to the minus 1. So the derivative is minus 1 x to the minus 2. And if I bring the minus 2, x to the minus 2 to the bottom, I get x to the positive 2. So the derivative of 1 over x is negative 1 over x squared. We've seen that many times. And of course, the derivative of x squared is 2x. All right, so why don't we just rewrite this a little bit nicer? So it's just basically minus 128,000 all over x squared. And now, like usual, to find a minimum or a maximum, what do? We solve the derivative equal to 0. So let's solve a prime of x equals 0. So 128,000 over x squared plus 2x equals 0. And if I bring this term to the other side, it's going to become positive. So 2x equals 128,000 all over x squared. If I think of this kind of as over 1 and I cross multiply, 2x times x squared is 2x cubed. 1 times that is still 128,000. Divide both sides by 2 to get rid of that number in front of the x cubed. These cancel. This is 64,000, right? And now we're ready to finish it. X is going to be the cube root of 64,000. Notice I don't put a plus or minus here. If it was x squared equals that, then I would put plus or minus the square root of 64,000. But since it's a cube, in other words, it's an odd number, I don't have to put plus or minus. I just do the cube root. And the cube root of that is actually 40. So we've actually found the number 40 here. We should really check, though, that it's... what are we trying to do? We're trying to find the minimum area, right? We want to minimize the amount of material used, so that means minimizing the area. How can we do that? Well, let's make a sine graph, I guess. We could do it that way. Now, notice here that since the domain is from 0 to infinity, we don't want this part of the graph, okay, because there's nothing going on back there. Everything kind of starts at 0. And I'm going to write an open hole there at 0 to indicate that there is no value there. And we found that 40 was our critical number. Let's think about the sign of the derivative here. What is our derivative again? It's actually just right here, isn't it? So if I put in a number into here, like say, I don't know, 20, let's see what happens. I'm just going to use my calculator. 128,000 divided by 20 squared plus 2 times 20. I get negative 280, so I know that this is negative here. And over here, if I take some number like, I don't know, 50, and put it in my derivative here, I get 128,000 divided by 50 squared plus 2 times 50, 48.8, so it's positive. I don't really care about the answer, I just care about if it's positive or negative. And I know at 40 it's 0, the derivative. This is a prime. And this chart tells me all I need to know. It tells me that it's decreasing and then it's increasing, right? So we do have a absolute minimum here at 40. So an absolute minimum occurs, maybe I should say of A, occurs at x equals 40. So that's the base of this box is going to be 40 centimeters by 40 centimeters. And the question did ask to find the dimensions, so we also need to find y, right? What was y again when we solved for it? It was 32,000 over x squared, right? So that's the number we got to put in for x there. So y is 32,000 over x squared. When I put in 40 into there, I get 32,000 over 40 squared. Let's see what that is. I type that in my calculator. I get 20. So the height of the box is 20. And we have now found the dimensions of the box that produces the minimum area. Let's write a little sentence. So the required dimensions of the box are 40 centimeters by 40 centimeters for the base. Remember, x was the base, dimensions of the base. And a height of 20. And that would be the answer, okay? Notice when I drew my picture back at the start here, I made the box higher than it was this way. So it's actually not like that. It's more, I guess, if I wanted to adjust my picture now, it doesn't really matter, but I can, just to be a little bit more precise, I guess. The box actually looks something like this, right? It's kind of shorter than I had drawn it before. So that's all there is for this question. Now, you notice this question didn't actually ask for the area. They didn't say, what is this minimum area? But we could easily find it, right? We would just put our numbers in this formula here, 4xy plus x squared. Why don't I do that just for fun? So the minimum area is, well, it's 4xy plus x squared, right? So it's 4 times x is 40, y is 20. Whoops, I made a mistake there. X is actually 40, right? So this should be a 40, not a 20. And when I type that in my calculator, let's see what I get. 4 times 40 times 20 plus 40 squared. 4,800. What's the units on that 4,800? Centimeters squared, right? So the question didn't ask this last part. It just asked for the dimensions of the box, which are given right here. But in case you're interested, this minimum area is 4,800 centimeters squared. All right, that's all for that.